All right, this lesson focuses on exponential growth models. Okay, so basically what this is going to do is it's going to take an exponential function and apply it to a story problem. Okay, so you've got the formula there, right there written. So y equals a parentheses 1 plus r all raised to the t power. Okay, so each one of these pieces means something. A stands for the initial amount. So whatever you start with, whether that's money or population, okay, that's what you start with. R stands for rate. Okay, so since we're talking about exponential growth this time, it's going to be a growth rate. Okay, usually this is given to you as a percentage. You have to change to a decimal before you plug it into your problem. And then T stands for time. Okay. All right, so first problem. You put $300 in savings, okay, that earns 2% interest compounded yearly. How much will you have if you do not make any withdrawals or deposits after 5 years? And then answer the question of what about 25 years? Okay, so the first thing you want to do is take your equation and figure out what your pieces are. Okay, so A, remember, is our starting amount. So we start with $300. R is our rate, so that's 2%, but if we change that to a decimal, that's 0.02. And then we have two different T's that we're going to use. We're going to use T is 5, and we're going to use 25. Okay, so we're going to have two different answers when we do this problem. Okay. So you first start with y equals 300 parentheses 1 plus 0.02 raised to the 5th power, and you have y equals 300 times 1 plus 0.02 raised to the 25th power. Okay, so we're going to take those and type them into a calculator. Okay, so for the first one, when you type it into your calculator, you should get 331 point, now have to round it since it's a monetary value, so it's money, so we don't want to keep writing the full decimal. So we round to our second decimal place, so to the hundredths place. Okay. Second one, again, same thing, plug it into your calculator. So you get 492.18. Again, that's a rounded value. Okay. So make sure when you're typing things into your calculator that this is what you're getting. Okay, and if not, you can always ask me tomorrow to get clarification on how to type it into your calculator. Okay, because I want you to be masters using your calculator so you can still do these problems. Okay. Next one. So population right now in a city is 192,000 and growing at 2% per year. What will the population be in 20 years? So same thing, identify your pieces. So A is our initial amount, so we start with 192,000 people. R is our rate, so 2%, which remember is 0.02. And then our T for this one's going to be 20. So then I write it out. So 192,000 times 1 plus 0.02 raised to the 20. And then type it all into your calculator. And you get, so we get 285,301.90027844. Okay, my question for you now that I want you to think about is, what are we talking about? So we're actually talking about people here. So we can't really have a decimal when we're talking about people. Okay, so I would just take this and just take the whole decimal place off. Even though it's 0.9, we're not going to round it. okay, because it's not quite to a full person yet. Okay, so we just take the decimal off. So we get 285,301 people. So then the last one, your dad owns an antique car that he bought for $3,500. If the car's value grows at a rate of 1.25%, how much is the car worth in 15 years? Okay, so A, R, and T. So A is our initial amount, so he bought it for $3,500. Our rate is 1.25%. Okay, so be very careful. It has a decimal place in our percent. Okay, that doesn't just mean I get to put 1.25 in. Okay, this actually means 0.0125 as a decimal. And then T would be 15. So then you take and write it into your equation. So Y equals 3,500 times 1 plus 0.0125 raised to the 15 power. Okay. All right, so we get 4,216.90. Again, I'm rounding this one because we're talking about money. Okay, we're not talking about population this time. So that's using an exponential growth model. Okay, so we'll do some more practice with that and identifying different pieces about that equation.